This question is from Q 2020 Mechanical Engineering paper set 2, question number 32. Two rollers of diameters capital D1 in millimeter and capital D2 in millimeter are used to measure the internal taper angle in V groove of a machined component. The heights capital H1 in millimeter and capital H2 in millimeter are measured by using a height gauge after inserting the rollers into the same V groove as shown in the figure. Which one of the following is the correct relationship to evaluate the angle alpha as shown in the figure? Sin alpha equal to H1 minus H2 by D1 minus D2. So we need to identify the correct relationship that will help us to calculate alpha. Basically, we need to calculate alpha using the two figures given. And it's told that diameter of roller on the left side, that is capital D1, is greater than D2. Now we can take a hint from the options that in order to find out alpha, we will have to use both rollers simultaneously. So let's do that. Let's stack the rollers together and then find it out. So this is the figure of the bigger roller. We'll draw the smaller roller in this itself. Here we have drawn it one below the other, but they can overlap also. That's not an exception. This is D2. Now, in order to calculate alpha, we'll make some constructions. We need a triangle, a right angle triangle, that's for sure, because we have to calculate sine of alpha. So that right angle triangle will be containing the angle alpha, this angle. What we can do is draw a perpendicular from this point, the point where the roller touches the groove. So if we draw a perpendicular here, this is 90 degrees. And let's name the vertices of this triangle. Let the centers of the rollers be O1 and O2 and this point be A. So we have a triangle here and let this point also be O. We have a triangle here in triangle OAO2. This is the right angle triangle OAO2. We can calculate sine alpha simply by using opposite side, that is AO2 upon the hypotenuse. Hypotenuse is nothing but OO2. But calculating OO2 is difficult because calculating OO1 is basically difficult. We only know the radius of this roller. We don't know this particular distance. So what we can do is draw a line parallel to this OA from point O1 so that we obtain this triangle, which is also a right angle triangle. Let this point be A dash. Now in triangle O1 A dash O2, in triangle O1 A dash O2, this smaller triangle, if I had to highlight it using the yellow hatch, yeah. So this is the triangle. Again, this angle will be alpha only because we have drawn a line parallel to OA. So angle A dash O1 O2 is also alpha. We can therefore again write sine alpha will be equal to, in this smaller triangle it will be A dash O2 opposite side upon the hypotenuse is O1 O2 here. This is the distance between the two centers that can be calculated easily. So now we know that this height is given H2, the distance between base to the top of this smaller roller. This is H2. So now we have to calculate A dash O2 and O1 O2. A dash O2 is this distance. So we have to particularly subtract the radius of this roller from the radius of the bigger roller. That will give us A dash O2. So A dash O2 is nothing but D1 by 2, radius of the bigger roller, minus D2 by 2, radius of the smaller roller. So this is simply D1 minus D2 by 2. Now we need to calculate O1 O2. This is a bit tricky. Make it real clear. So this total is H1. We need to calculate this distance between the two centers of the rollers, O1, O2. So basically if from H1 we subtract this, which is half of the diameter of bigger roller, this is nothing but D1 by 2. This distance from here to here is D1 by 2. If we subtract this much, we will have this total distance, and then we will have to subtract the distance of base from O1, which will be nothing but H2 minus D2 by 2. So we have O1 O2 as H1 minus D1 by 2. This gives us this much distance. And then we have to subtract this distance from it. This distance is nothing but h2 minus the radius of the roller, this much. So that will give us this distance which we have to subtract from the h1 distance. h2 minus radius of the roller d2 by 2, radius of the small roller. Let's rearrange this. We have h1 minus h2. Taking these two other terms together, we have minus of d1 minus d2 by 2. Let's calculate sin alpha now. We have sin alpha equal to this upon this, d1 minus d2 by 2 upon h1 minus h2 minus d1 minus d2 by 2. Let's just multiply the numerator and denominator with 2. So we have d1 minus d2 upon 2 into h1 minus h2 minus d1 minus d2 again. Let's go back and mark the correct option. So the answer that we calculated here is given in option B. Sin alpha can be calculated using this relationship. Biggest hint here is that we have to use both the diameters and both the heights together to find out alpha and construct the appropriate right angle triangles. To learn more about rolling, you can refer to the NPTEL video Lecture 19 Analysis of Rolling from the course Plastic Working of Metallic Materials. It is by Professor P.S. Roby. He is from Department of Mechanical Engineering of IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.